Hello, everyone. Thank you for coming to our session on SIG Storage. My name is Xing. I work at VMware by Broadcom.
Hi, I'm Michelle. I work at Google.
I'm Hemant. I work at Red Hat.
Here's today's agenda. We will talk about what is SIG Storage, what we did in Kubernetes 1.33 and 1.34 release, what we're working on in 1.35 and beyond, and finally, how to get involved. In SIG Storage, Saad and myself are co-chairs. Michelle and Yang are tech leads. Other than the leads, we also have many other contributors. What we do in SIG Storage is defined in our charter. We maintain Kubernetes APIs related to storage, like persistent volume claims, persistent volumes, storage classes, volume snapshots. We also maintain code around those API objects, like dynamic provisioning of volumes and snapshots. We maintain volume plugins, like NFS iSCSI plugins. We co-own projected volumes, like secrets and config maps, with SIG node. We designed container storage interface CSI so that storage vendor can write a driver that allows their storage system to be consumed by containers running in the Kubernetes cluster. We maintain CSI sidecars. CSI sidecars watch Kubernetes API objects and trigger appropriate volume operations against a CSI driver. Most CSI drivers are owned by SIG cloud provider or other communities. We also designed container object storage interface COSI that provides APIs so that you can provision a object bucket, just like how a PVC is provisioned. Now let me talk about what we did in 1.33 release. The volume populators feature moved to GA in 1.33. Previously, you can create a PVC from a data source that is either a volume snapshot or another PVC. But there are use cases that require us to pre-populate volumes with other data sources. For example, during a backup, you first create a volume snapshot from a PVC. You upload that snapshot data to an object store. Then at the restore time, you want to be able to create a PVC from this backup. So this backup will be another external data source that is not a PVC or a volume snapshot. That's why we introduced this feature that allows generic data populators by permitting any object from the data source for a PVC. We introduced a new data source ref field. If the original data source is specified, it will be copied to the new data source ref field. The original data source will always be supported. There are some differences between those two fields. Data source is for local object only. Data source ref can be any object from any namespace. That makes it possible to support cross-namespace transfer in the future. Always owner PV reclaim policy also moved to GA in 1.33 release. Without this feature, the PV reclaim policy is ignored sometimes, depending on whether you try to delete PVC first or try to delete PV first, leaving storage resources behind. That's why we introduced this feature to prevent volumes from being leaked by always honoring the PV reclaim policy. This feature is now GA. It is ready to be used in production. In 1.33, we also moved Portworx CSI migration to GA, secure Linux labeling with mount options for non-rewrite once pod volumes moved to beta. We also have a new alpha feature, mutable volume attach limits. Hemant will talk more about it later. In 1.33, change block tracking feature was introduced as an alpha feature. It provides gRPC APIs so that a backup application can retrieve snapshot metadata of allocated and change blocks. This allows us to support incremental backups. In 1.33, we also have another alpha feature called storage capacity scoring. Previously, we have scoring logic in the volume binding plugin to support static provisioning. With this feature, now we also have dynamic provisioning support. An admin can configure kube scheduler to prefer a node with the least or most allocatable capacity. This feature is also replacing volume capacity priority, a feature introduced earlier. Now these two features are consolidated. In 1.33, we announced the removal of Git repo entry plugin. This plugin has been deprecated for a long time, and it is unmaintained. There are security concerns. This plugin can be exploited to gain remote code execution as root on the nodes. There are alternatives. You can use Git sync or init containers for the same functionality. So in 1.33, we disabled this entry Git repo volume plugin by default, and we are planning to remove the driver code in 1.39 release. Now let me hand it over to Hemant, who will talk about what we did in 1.34 release.
Thank you, Xing. So let's talk about what we worked in 134 Kubernetes release. If you have been expanding your, like using volume expansion, you might have run into this issue where you want to expand the volume from 1 terabyte and you just mistyped it, or somehow you just entered 1,000 terabyte and that operation didn't work. And previously, you will be stuck actually. You'll have to ask your cloud provider or storage provider or cluster admin to bail you out, and it required a bunch of manual intervention, and it was not nice user experience. In 134, we have made it possible so that you can retry, you can reduce the size of your PVC and retry the volume expansion, and it works just the same. So as long as your new request is higher than the previous value. So it allows users to themselves recover from volume expansion failures. We have improved how we report resizing status in PVC now. You can see the statuses. And we have fixed many long-standing bugs, race conditions related to resizing under the hood changes. So overall, the operation should, the resizing should be much more robust in Kubernetes 134. One of the other features that we GA'd in 134 is a volume attribute class. The idea is that let's say you're running on AWS and you want to convert a GP3 volume to IO2 because your application needs more performance, more IOPS, more throughput. Previously, it was hard. You had to go open AWS console and do this, and it was tedious. So with this feature, the idea is that admin defines a volume attribute class like so. Like there's a volume attribute class silver, and it has parameters such as IOPS 5000, and this PVC is associated with volume. It could be created with a volume attribute class silver, and later on, if I need more IOPS, my cluster admin has to still define the volume attribute class, like this gold, because these are volume attribute classes are cluster scoped objects, but the user can choose which volume attribute class they want, and I can modify my PVC to target a better volume attribute class if I want. So this basically makes modifying the PVC attributes of a volume anytime after provisioning. Previously, this was not possible with storage classes because they cannot be changed once you assign them, but volume attribute class can be changed after creation. And one of the other features we moved to beta in 134 is mutable volume attach limits. And it's better to explain this with a diagram. So again, using AWS as an example, you have a node and it has these 3 volumes attached to it. And these are the empty slots, the other volumes you can attach to the node. You may be aware of it, but on AWS, if you attach more ENIs to the nodes, like 2 I attached here, Another I added here, as you attach more ENIs, number of volumes you can attach to the node reduces. So the limit previously used to be fixed, and it was unchanging. The problem was, like, you can get into a situation where a scheduler is sending pods to a node and they cannot run there because the node is out of attach limit. So with this feature, we have made it mutable. Kubelet watches for, driver can report this limit periodically. Kubelet watches for the change limits, and it bubbles up this information all the way to kube scheduler so that it makes better decisions based on whatever the limit is. And kubelet can also reject pods if volume cannot fit, if the pod cannot fit on the node anymore. So another feature that we moved, it was beta, but we moved from beta 1 to beta 2 is volume group snapshot. The idea is, like, you have an application that uses more than one volume. Like, I don't know, Cassandra application that uses a bunch of replicas, and you want to take a consistent snapshot of all the volume that the application is using together. Previously, it was tedious to do, so we introduced this API called volume group snapshot. And with this, there are 3 new types: volume group snapshot content, volume group snapshot class. And then we had to make changes into CSI spec as well, and to make this happen. So we introduced group controller service and propose new RPC interfaces for creation, deletion, and getting volume group snapshot. The reason we had to move from 132 beta 1 to beta 2 was we found some problems with the earlier implementation, and we had to make changes in the newer beta 2 APIs. If you're using volume group snapshot, I will recommend you to read this blog about what changes went into beta 2. And with that, I will hand over to Michelle to talk about.
All right. Yeah, I'm going to talk about what we are delivering in this upcoming 135 release, which is supposed to be released, I think, in December, and also talk about what we're going to do beyond 135. All right, so targeting beta is a new feature for CSI drivers that need the pod service account token. Drivers like the secret store CSI driver, for example. This is a security improvement that will pass the pod service account token through the secrets field instead of the attributes field. That way, it can help reduce and prevent some common logging CVEs and things that have happened in the past in these drivers. This feature does require the CSI driver to update their code to be able to handle it. So if you're writing a CSI driver that wants to use this feature, be sure to look at the KEP. The KEP has some very detailed rollout and recommendations on how to actually adopt this feature in your CSI driver. Staying in beta, but enabling by default, is the mutable volume attach limits that Hemant was just talking about. And then staying in alpha, but moving to V1 Alpha 2 is the Container Object Storage Interface, also known as COSI. With the move to V1 Alpha 2, a couple new features were added, such as supporting read-write access modes, allowing the bucket access to specify multiple buckets, and also redesigning the sidecar and the controllers to be able to solve some version skew challenges, and as well as improving the security posture by reducing the amount of RBACs that you have to give to the sidecars. New features that are introduced in 135 as alpha include adding the CSI volume node limits support with the cluster autoscaler. So this is for, this is basically making the autoscaler aware of the attach limits on the nodes that it potentially needs to scale up. We are going to have initial implementation in the cluster autoscaler for providers that use the cluster API. But if you are supporting a CSI driver on a provider that doesn't use Cluster API, then you're going to have to integrate into the Cluster Autoscaler repo with your own implementation for that provider. Along with this feature, this will allow us to also update the Kubernetes scheduler so that we can schedule pods to nodes where only the CSI driver is installed. There are some environments, especially on-prem environments, where the CSI driver might not be available on all of the nodes. And so this feature bundled with the autoscaler feature is going to allow us to be automatically restrict the pods based off of that. Another new feature we're adding in alpha is the ability to mutate the persistent volume node affinity. So this is for drivers that can basically change the topology of a volume in a non-disruptive manner. What I mean by this is that the driver or the storage system needs to be able to support updating topology while existing workloads are running, and they can do so in a way that doesn't cause disruption to existing workloads. So initially, this feature is not going to, orchestrate any sort of workload migration or workload up sort of disruption for the drivers that can't do it in a non-disruptive manner. Okay, and so that's what we're adding in 135. Beyond 135, there's a number of features that are currently in discussion and prototypes. First is the ability to expand the volume through the stateful set volume claim templates. Today, you have to go directly to the PVCs to expand volumes. But yeah, we're going to integrate and work with SIG apps to actually make that happen through the stateful set template API instead. Another feature that is very useful for CSI driver authors is to combine all of the CSI sidecars into a single component. Today, we have about 5 or 6 different sidecars that you need to integrate into your CSI driver, and it's a big pain from our side to also just release them on time, and to the versioning is kind of all different. And so we're going to try to simplify that whole process by combining everything into a single component, just a single release. And in addition to just the maintenance simplicity, we also get benefits from being able to reduce the resource overhead that the sidecars take. And so with this, you'll be able to actually reduce the amount of memory and CPU footprint that a CSI driver consumes. Another feature that we are discussing now is volume health. It's currently in alpha, but we are discussing how to promote it to beta. As part of the promotion to beta, we want to improve the way that the volume health status is reported. Today, it's only reported in events and metrics. We want to actually report it in an API, and also add more fine-grained signals to volume health, basically more statuses, and also some more detailed timestamps of when the last event was seen. This is going to allow people to, better debug their systems and also potentially add automation to how to recover from some common scenarios. All right, so that's kind of everything that is on the plate. If any of that interests you and you want to sort of get involved, we have bi-weekly meetings, 9 a.m. Pacific, every other Thursday. We have a mailing list. You can also send emails and ask questions there. And we have a Slack channel as well. So we'd love to have more folks join and participate and, just give us feedback, or even if you want to contribute to features, I think we welcome all new participants. Right? And then on this presentation, which I think will be available on the page, we have a bunch of links here for just concepts of PVCs and PVs. We have some documentation on how to write a CSI driver and some sample driver implementations you can look at. So feel free to look at those if you're interested. All right, and we'll leave the rest of the time for questions. Oh yeah, if you have a question, there's a microphone over there in the center.
So, my company develops a CSI, driver, and one of the things that CSI driver does is it's basically a layering CSI driver. It takes, an existing CSI driver, say, NFS storage CSI driver, layers something on top, and then, our CSI driver takes that CSI driver, layers, a layer file system on top of it to provide, securities and whatnot. One of the issues that I have with that approach is that since I cannot auto-scale on a pod a persistent volume, a PVC, every time I need to create some pod is going to use my driver, I need to create a staging pod to expose the mount of the original CSI driver so that I can actually protect on top of it. So the question is there, has there been any consideration to supporting layering file systems, CSI drivers that need to layer on top of other drivers? In my particular example is for security. But are there any for example Union FS or things of that nature? Has there been any consideration on that? And if so, how do we get involved into helping create that infrastructure?
So if I understand correctly, you're building a CSI driver on top of another CSI driver, so you'll basically have two PVCs in play, right?
Two PVCs in play, correct.
Yours, but then you'll have the underlying CSI driver.
Correct.
And I think, like, I haven't seen that before, so that's pretty cool. But I would think the main way to get that to work is your CSI driver might need to manage the underlying PVC. Right.
So it does it right now. It
Okay.
does it right now, but it does it in order for me to do that, I actually had to launch another pod that doesn't serve any other purpose other than just mounting, mounting the
Oh, I
underlying
see.
PVC. And I would like to see if I can get rid of that mechanism.
I see.
It's a very, it
Yeah.
works, but
Yeah, because in order to attach something, you need to have a pod. Okay, interesting. We haven't thought about it, but I think it's a really interesting use case. So I would,
Can I talk to you after?
yeah, let's definitely talk and brainstorm.
We have a time. That's really thank you for your some contribution and then talking today. Yes, really good. My question is little okay. My question is very simple. So for the education purpose, that what kinds of some storage class do you recommend? I mean that this currently I use that this NFS sub blah blah blah. You may know that the NFS previous time this I forgot the name. It is thank you. NFS sub blah provisioners. I use that as one, or sometimes probably the host path is possible, but host path is limited. So what kinds of some storage classes do you recommend for educational purpose or testing purpose?
Sorry, can you repeat that a little more slowly?
Okay.
And also a little bit away from the mic.
Ah,
There's a
okay.
lot of
Sorry,
echo.
I thought this mic is okay. My question is that there is so many of the storage classes exist, and for the education purpose or testing purpose, I use that the NFS subdirectory provisioner, right? Yeah, I use that the once, but I just want to know about the some SIG storage side. Is what kinds of storage class do you recommend for testing or education purpose?
Yeah.
Yeah, the host path drivers, the CSI driver is a good example. You can use it for testing, development, and learning CSI, and it allows you to like execute hooks actually, which you can change the behavior however you want. So that's what we use for all our, not all our, but a lot of our end-to-end testing.
So which storage class do you recommend? Sorry.
The host path, CSI host path.
Hostpass, but Hostpass is really limited to use that. So is it just designated as one node? So is it not easily to use that as some like as a read write menu or something like that?
There is a CSI NFS driver as well. You can use that, but like I was answering for the testing and development purposes.
It depends on what you're testing. Like
Yeah.
the CSI host path driver is used for us to test Kubernetes and CSI behavior itself. So like that driver has a bunch of maybe a little weird behavior because we basically like try to inject failures into the driver and things like that for our tests. But if you're testing like an application that needs some basic storage,
Yeah.
then yeah, I think something like the NFS driver would work well. If you have multiple nodes, but you don't really care about sort of like resiliency across nodes, there's also a local path driver or something like that, which is basically just it's like a directory on your local node, and so that could work as well.
Okay. Thank you.
And if you want something more complicated, you can go root
Hi. Thanks for the talk. I saw there was a slide where you mentioned there was a sub-meeting on data protection. I'm just curious what kind of things are currently being discussed in there besides the change block tracking.
Yeah, so that feature right now is alpha. We are trying to move it to beta. So if you're interested, we have a bi-weekly meeting. You can come and see if you just want to use that feature or you want to help contribute.
I was curious, besides change block tracking, what kind of things are being discussed in that meeting now?
Oh, there are other features. Yeah, there was actually a session about data protection working group. It's a Tuesday. Yeah, so we actually talk about that. So we also discuss like volume group snapshot and like volume populators, cozy. So a lot of those features already moved to GA or they are in beta phase. But we are tracking all of those because we're talking about like the backup and restore workflows. So for that workflow, you need to take a snapshot and then you upload data to your object store, and then how do you do restore after that? So we discuss all of that. So if you're interested, yeah, please come to our meetings and see if there is anything other than those that you want to discuss.
Okay, thank you.
Yeah, volume replication was also something that we started to discuss. We have not reached a consensus on how to do it yet, but that's definitely something that we would like to look into.
Great. Yeah, I'll probably come to one of those meetings.
Okay, awesome.
Hey, thanks for the session and contribution. So my question is, since now the CSI is pretty much used by everyone, right? And then there are advanced storages available. How we are thinking about doing a disaster recovery in all those across two clusters? Are there any discussion going on in the community for the DR kind of stuff, or this is something taken care by some other SIGs or something?
Disaster recovery, you are talking about like a cross cluster?
Across two Kubernetes cluster or OpenShift cluster.
Oh, so you are talking about class level disaster recovery, or because we are so in data protection working group, we kind of right now we are focusing on like application, backup, restore, or maybe replication in the future. So it's more like your workloads, your application deploying a namespace. So if you are talking about, are you talking about even the whole cluster itself, or just the cluster resources? Because the solutions we have been discussing so far require you have a Kubernetes cluster there, and then you deploy your backup with your applications there, right? So if you're talking about protecting the whole cluster, that's something we didn't really get into yet. But is that something that you're interested?
Yeah,
or?
so most of these storage backends, right, the enterprise backend, they have replication, data replication at their level, not at the Kubernetes level, right? So
Right.
they have their sync async configured at their level. What we want is just an PV layer, the whole synchronization of PV or PVC related stuff at higher level, right? So there are no standards available now. There are custom things being used, right? But is there something that in that direction going on? Or?
So okay, so it sounds like you're talking about volume replication. Your basis, right? Array replication. Yeah.
Yeah.
So we were actually just mentioning that earlier. That was something we discussed a little bit in the data protection working group, but we have not reached consensus yet because it's a pretty complicated topic, and also different backup vendors, they have their own solutions already. So we just want to come up with something that works with most people. But if you're interested, please join our data protection working group. Then we can discuss about that.
Sure. Yeah. Thank you.
So, hi there. Thank you for the talk and contributions. You mentioned volume health. I personally am super interested in that in terms of saying, oh, if you were to publish events and things onto the PVC, of the health of it. My question would be, what benefits are you gaining from creating an API? Is it a pub sub model where if you publish the volume health onto an API, making it standardized, then other people could subscribe to that? And how is that different from maybe like the events that you are potentially already publishing on those?
So let me know if I got it right. So you're asking like what benefits we get by projecting volume health in as API objects, or?
Correct. Kind of what limitations have you found in terms of volume health that you needed to dive into developing API specifically for volume health, since I'm interested in that myself?
So the current implementation that is alpha, that's been alpha for a while, is just in form of matrix actually. So and events. The problem is events are ephemeral, and and the matrix is the way it's been designed. It's not many. When we talk to some of those storage providers, they don't find it actionable actually. They like, so we are trying to provide unified health that is associated with the PVC, so that a user knows, okay, this PVC is having this problem, and that information doesn't go away. For example, if the PVC moves to a different node, if the health issue was because of, let's say, there are some control plane issue. There could be control plane issue, there could be issues specific to node. So we are trying to differentiate those two statuses and report them separately, but on the same object. We are still discussing how it will look like in terms of API, but the idea is that users should be able to see all this information in one place, potentially, and there could be higher level operators that can take safe actions that's possible, like move the pod to different node, or yeah. So we're working towards that. We are love to hear feedback because we're still designing it, and how you want it to be useful to you. And please join our SIG storage call, or we had one meeting just for volume health. We will have more meetings just for volume health. So if you're interested, please join us. And yeah.
Awesome. Sounds good. Thank you.
Hi. I'm not in the storage space. I'm on the Netflix compute team. We've just migrated our data plane to kubelet containerd. We are using CNI for networking, but we have not yet fully embraced CSI. I think that we've looked into it, and also kind of backing up a little bit. Netflix doesn't really have a strong Kubernetes muscle yet in terms of the data plane. We do on the control plane side. And I think we have a solution right now that doesn't use sidecars, doesn't use host daemons. It's all kind of self-contained in a binary that we execute. But we really would like to move towards CSI. I think it's a very, at least for us, is we're struggling a little bit to kind of figure out how to meet our requirements with CSI. So this is not a question, more like introducing myself. And I saw that you guys have the meetings, bi-weekly meetings. So I think we're going to start attending and maybe surfacing some of our problems. I think what we need help is mapping our requirements for storage to how we would do this in CSI, and also maybe surfacing some of. I think you saw. Yeah, that's a slide that you're consolidating sidecars into just one. I think that was also perceived as like, we're not so sure we want to do have so many sidecars as well. But also for anybody in the room, if this is something that you're interested or you have experience with, please come talk to me as well.
Yeah, I think it's really cool to see like non-Kubernetes distributions also leverage CSI. I think from a historical perspective, CSI was actually designed not as purely a Kubernetes thing. We worked with other orchestrators like Docker and Mesos to design the CSI spec. So while it is influenced a lot by how Kubernetes operates and deals with storage, like I think it is leverageable outside of Kubernetes.
Yeah, and also to clarify, we are all in on Kubernetes now. It was just the data plane was using the virtual kubelet, and we had to mock the kubelet interface and do all our container lifecycle management manually. But we just migrated that to the real kubelet. But the holdoff was the storage story. We did embrace CNI, and that's working for us. But also the challenge for us is that there's a separate storage team that's sibling to the compute team. But I think the idea is that we use CSI as a contract between teams, so that like if you own the CSI story, the daemons as sidecars, and we kind of interact via the contract. So I think that's like the long-term vision that we want to get to. But yeah, not a question, just
Yeah.
saying hi.
Yeah. Yeah. If you have new use cases where it's not working well, then let us know.
Yeah, I'll share a blog post that a teammate wrote about like why it doesn't work for us. But yeah, thank you.
Thanks for the presentation and thanks for working on the CSI drivers and helping the community. Our company develops CSI drivers, and with the AI use cases, we are seeing more demand for features like automatic volume expansion. Because you add a couple of features catering to volume expansion, just wanted to check if you have automatic volume expansion also in the roadmap for the next year or two.
That is definitely a topic that has come up a bit. I think there is actually there is some project that wrote a like automatic resizing controller that you can use. It basically uses the volume capacity usage metrics, and then you can configure some thresholds, and when it reaches the thresholds, it will automatically go and resize the PVC object. So I think that controller already exists outside. It's not a SIG storage project, but I do think it is there.
Yeah. So what Michelle says is correct. Yeah, there are operators that do that. The problem is like they use matrix to make the decision, and the way we report matrix in kubelet right now, if your pod is not running on that node, unless you're persisting that data, and like that information will not be available anymore. So like you scale down the pod. So it's not 100% like I would say reliable, but people are making it work. It's just that the matrix disappear when the pod is not running on that node. So how much is available capacity? So making decision based on that to automatic expand, yes, it works for the most part, but Yeah, like we haven't decided like as such plan automatic expansion feature at the SIG level actually.
Okay. Thank you.
Hi, thank you for the talk. What's your current setup for testing object storage for Cozy? Like, what are you using?
Well, I am actually not really using Cozy. I think Blaine, think he's not here today. Yeah, we do have a README. If you go to our the GitHub, it has a README, and there are some steps on how to test it. So do you have a Cozy driver, or you just want to play with it, or what kind of storage backend do you have?
Looking to play with it. I work for a storage cloud provider, and we read about your project, and so we're looking to get involved and also see if you all need some more free infrastructure to help with your testing. So I was going to attend the meetings or start attending the meetings, but if there's more of a direct line of someone that I need to talk to, that would be great.
Yeah, so have you been on the Cozy channel? There is a Slack channel for Cozy.
Yeah.
And we also have meetings, there's weekly stand-up meetings.
Okay.
So come to those meetings. Yeah, we do have I think we do have like a sample driver. Yeah, come to that meetings or just ping us on Slack and find that out for you.
Okay, great. Thank you.
Yeah, thank you.
Sorry. So hello, thanks for the talk. It was really helpful to hear everything going on. We definitely need some of the new features coming up in the next few releases. I'm currently at a enterprise blockchain startup. We built a CSI driver using LVM and AWS EBS to kind of glue volumes together and allow for auto-expanding storage. As a result, we've ended up building kind of like an intermediary lifecycle of a volume underneath the PVC to help track the metrics that you were kind of describing and status and things like that. It's a project we're maintaining internally, kind of proprietarily initially, but I think that's not the goal in the long term. We want to swap out sort of the interface where we manage EBS and plug in Google Cloud and Azure. And so I'm just kind of wondering, through attending SIG Storage and that kind of thing, what's the appetite for sharing some lessons learned and that kind of thing as I guess I'd love to open source it. I think I have to go through a lot of hoops and yeah, that kind of thing. But I feel like there'd be a lot to discuss, basically. And has that been kind of a thing in the past where folks attend, share snippets, but can't share code quite immediately, or yeah, that kind of thing?
Yeah, I think this also aligns well with, I think, an earlier question about like building a CSI driver on top of other CSI drivers. Sort of.
Yeah, we avoided doing that just because that sounded more complex. So we kind of inherit actual like open source CSI driver code for direct EBS management, for example. But then we wrote the whole driver ourselves so that it's just one PVC for our simplicity with with a little.
But I think it's also just like in terms of like helping you be able to expand coverage to other providers, right? It would be more modular if like you didn't actually have specific provider information in your driver. But but I think definitely like we would love to hear about lessons learned and things like that. I think in our bi-weekly Thursday meetings, we always leave some time for people to give presentations and stuff. And so you're welcome to also join those meetings and add your topic to the agenda.
Cool. Yeah, that'd be great. I think, like I said, I'll be chatting with folks internally around what we can't share. I don't think it's actually that much secret sauce, but that'd be awesome.
Yep, sounds good.
And yeah, maybe avoiding the in-tree problem I think you were alluding to, right? Like keeping things modular so the other bits live outside. Cool. Thanks.
Hi. We are using OpenEBS for dynamic storage provisioning, and we found a couple of quirks around some of this, the dynamic persistent volumes that are created. Sometimes all end up on the same node when we have deployments or stateful sets that try to spread the compute over all of the nodes and whatnot due to your normal node affinities and whatnot. But is there an interface in CSI that's supposed to kind of allow for applying the same sort of node affinities for those dynamic provisioners? Like, if it's something that they should be doing, I would be happy to go in and help them fix it.
Sorry, so is this OpenEBS?
This is OpenEBS.
Okay. And the challenge is that
They create deployment and many of them end up. So if I understand correctly, like the challenge is that you create many deployments and they all end up on the same node or same set of nodes, and you want this to be as spread as evenly as possible.
Yeah, it basically doesn't have any affinity awareness, so it just picks whatever node has the least storage or the most storage available. And I'm not sure if there is an interface that allows that kind of node affinity or topology awareness.
Yeah, so I think there's a couple of different ways to deal with this. One is at the driver level itself. Like, I'm not familiar with OpenEBS features and what they support, but like at the driver level itself, they could have some sort of spreading policy, right, to prefer kind of spreading volumes across different nodes. But at the Kubernetes level, the main way to do this is like to basically add pod anti-affinity across your deployments. And so that'll basically, the scheduler will prefer spreading those deployments across different nodes.
Yeah, so that's how we tried to do it. The problem is that the persistent volumes become node bound separately to the pods. So then the pods are forced to be deployed wherever the PVs are created.
That is, I think OpenEBS is local storage, right? No?
Yep.
So this is one topology. This is not like different topology deployment of OpenABS, right? It's one topology. And
can you repeat it?
Is this the storage is like the volume that you're creating? Are they are they zone aware? Like, or is this just all storage available in one zone? Is it single zone or multiple? Is there a concept of zone in OpenABS?
I mean, we use it for a couple different kinds, but yeah, usually it is zone aware. If we were to do that, we definitely could have created these things, but usually for like our Helm charts, we just specify a storage class and then call it a day.
Yeah. So there was a plugin actually in Scheduler that got deprecated and removed, I think, couple of, I don't know when, but there was a plugin that tried to distribute the balanced volume plugin, it was called, that tried to spread the pod that are using volume based on like how is that, but it was removed actually, nobody was using it.
We have logic for within a single stateful set, we will try to spread the topology across different nodes. But that's within a single stateful set, right? If it's across different deployments, then I think like the pod anti-affinity is the main thing.
But there was a scheduler plugin also contributed by Red Hat, but then I don't know what happened. It just got removed.
Okay.
If you're interested, if it's useful to you, then.
But the issue is you have different deployments, and they're all ending up on the same node.
This is within a single deployment.
So you have multiple replicas in a single deployment, and they're ending up on the same node.
Yep, deployment or stateful set.
So that I think you just add the pod spreading constraints to your deployment.
Those do not work.
Then it could be, I don't know, then this sounds like this might be an OpenEBS challenge, but...
Like, I'm just trying to think like, so, oh, this is read write once volume, right?
Yes.
Yeah, and you're scaling the deployment to multiple, more than one replica, and it may be something OpenEBS specific, because the problem is that we do not recommend running deployment, scaling a deployment that uses read write once volume to more than one replica, because we cannot guarantee that the other pod will land on the same node. So if it lands on a different node, then that pod cannot start because the volume is attached to the first node, and the volume type is read write once. So
That's fine with topology. Like if your storage class uses the wait for first consumer mode, which is basically the topology mode.
But you're using deployment. You have already put it. You have already put a PVC on it.
Oh.
That doesn't happen.
If you have, okay, I think with a deployment, all the replicas share a single volume.
Yeah, exactly.
No?
Yeah, with deployment,
With a deployment, there's no persistent volume template, so every replica shares the same PVC. And with stateful sets, every pod gets its own volume. So that's...
Yeah, sorry. Assume I was talking about stateful sets the whole time.
Okay, so I think in that case, you still need in your stateful set spec, you need to add the topology spreading constraints. And you said you added that, but it's not working.
My guess is it doesn't truly support bind on first consumer, and it just creates the persistent volume, and it's already bound to the node when it
yeah. I think it's sounding like maybe there's either a configuration thing or OpenEBS is not supporting the topology mode. So I think this is something that probably you'll need to bring up with OpenEBS folks. I think unfortunately none of us are OpenEBS experts. So
I'm more than happy to go into this. I was kind of just wondering what the APIs were for those sort of things, but if it is just figuring out why binding for first consumer is not working correctly, I can handle that and bring that to the team.
It is supposed to, like if you have the topology spreading constraints set on your stateful set spec, then it should try to spread it across your different topologies. So that is the intended behavior. So if it's not actually working, I think I would check with OpenEBS first.
Will do.
I do have. Sorry. I do have one more question. It's not so much a question as a customer experience that I have with some customers using our products. If you're developing new file systems, unless the file system is in the kernel, you have to be using a fused file system in order to provide that functionality. Problem with fused file systems is that if we tell the customers, and it's on the documentation, says, if you have a volume mounted, do not kill the daemon set. Some customers don't listen, and we basically lose connection to our, it would be nice if there's some feature that would say, if there's a volume mounted and you try to kill that, that daemon set, either don't allow it or something, because, you can do finalizers, but finalizers prevent the object from disappearing. It still kills the pod.
Yeah, so I think with that, so if you want to say block certain actions from happening, I mean, one way of doing that kind of generically is to have some sort of webhook, right, that can reject the actual delete request. I think, I forgot API Machinery was working or was discussing some feature for pod admission. Like basically a finalizer, but it actually prevents the the actual API requests from coming in. I forgot the name of it, but it was something that API machinery was discussing. So but I don't think it exists today.
Sorry, who is working on it? So I can make a note. SIG API machinery.
Yeah, So we were discussing with SIG API machinery, like basically a different alternative to finalizers where it actually prevents the API requests from going through, right? So that kind of addresses your question of like, the finalizer doesn't actually prevent it from the API deletion from going through, right? It just delays it.
Okay. But someone is working on it then?
I don't think anyone's working on it. It's something we discussed and brought up with them in the past, but I don't know if anyone's working on it. But like, I think if they hear more about like your use case, then it's something that like the SIG can start looking at.
Yeah. I'm sorry?
How are they killing the pod? Like by?
Well, it's usually. I don't know. They have processes that, my applications, is consuming too much CPU, and they, some system administrator that doesn't know anything about it just basically starts killing things. And then they say, well, this application is consuming a lot of CPU. It consumes a lot of CPU because we do encryption. They kill the pod, and then all of their other, applications that were depending on that volume, kind of die.
Yeah.
And it's an education thing. We tell customers, it's on the documentation. It's on this page. Don't kill your pod. But
Yeah, I would just.
it happens.
Yeah, I would say like today, out of the abilities we have today, probably an emission webhook is the best thing you're gonna be able to do today. Yeah.
Like logging to the node and just kill -9 they're doing or something like that, or they're killing the container by CRI/CTL. Then
Yeah, if the user just SSHs into the node and just starts killing processes, then that's not going to prevent it. But at least if they're trying to kill it through the API, like if you have an emission webhook, you can block that. That's like the best solution we have today. In terms of just like Fuse CSI architecture, we don't have like specific like features to support that, but at least my team, we have written a Fuse CSI driver, and we actually came up with 2 different architectures to try to solve the problem of like both Fuse resource allocation in terms of like attributing the resources that the Fuse process uses to the workloads. And we've also tried to sort of solve that lifecycle problem of like, how do you actually upgrade and coordinate the, like if you want to update the Fuse process itself or the CSI driver. And so, but yeah, my team has kind of talked through like 2 different architectures. We have one architecture in production today. It definitely has its pros and cons, and so we're also discussing.
Yeah,
and
for upgrades, we
designing
tend to use operator for that, and that we need a separate process that actually has knowledge of volumes in order to actually handle the upgrade gracefully.
Yeah.
But I can't do Helm upgrades don't work very well with that kind of philosophy.
Yeah. But actually, we have a second architecture that we've been sort of brainstorming. Like I'd be happy to discuss it with you offline. We haven't actually put that one into production, so I can't promise like it actually works, but like it might be something you might be interested in.
Thank you.
All right. Any other questions? Oh, sorry. All right. Go have lunch. Thank you.